and got everybody back from testing, so. Okay. Pythagorean Theorem. So, where was I? So, Pythagoras. I showed you how they would do proof before they had Hindu Arabic numerals. I'll show you a proof of the Pythagorean Theorem later as well, a more recent one. There's got to be, I can think of 3 that I could have for you, but here we go. So in this case, okay, we can see that the hypotenuse has got to be an irrational number, doesn't it? Okay, there's no other alternative. Irrational numbers exist. They're weird. They don't repeat. They don't terminate. It's hard to ever say exactly what they are, but they do exist. But Pythagoras and his followers thought that every number could be written as a fraction of integers. Okay, and that there were irrational numbers. They didn't, well, of course, they didn't have a word for them or anything like that, but they just thought that every number could be written as a fraction of integers, but we know that's not the case. Pi is not exactly 22/7, and it doesn't matter, you know, how you do it. You can't get exactly pi as a fraction of 2 integers. That's just it. So, you guys are pretty familiar, I think, with the Pythagorean Theorem. Who's done it before? Hands up. Okay. It simply says the square of the sum of the 2 legs is equal to the square of the hypotenuse, right? When we do this, make sure that you square the legs before adding them together. So a big mistake I see a lot is people will say, well, this is 10 squared. So they'll add the 3 and the 7 first and then square it, but order of operations tells us what? You gotta do the exponents first, right? Okay, so be really careful about that. If I were just going to do this on my calculator and get a decimal answer, I would probably do something like this. I would say 3 squared plus 7 squared, enter. And now if I need the decimal for the square root of 58, say to 1 decimal or 2 decimals, how am I going to do this? Am I going to go, okay, second function, 58, and hit enter? Or if you've already got it in, the calculator, you can raise it to what power? You guys remember? The 1/2 power. So raising something to the 1/2 power is the same as taking its square root, taking its second root. And a lot of times this can be a lot faster to do. So, you know, especially if you have some bigger numbers. Say I have like one leg is 47 and the other leg is 63. So when I hit enter, what's the calculator going to do? Is it going to add them first and then square them? What's it going to do? Square them, then add them. And then that's not the length of the hypotenuse. The square root of this number is, right? So if I want the square root of that number, I can just raise it. See this up caret button? You guys see that on the board? See the little up arrow? So it's called an up caret. And I just raise it to the 0.5 power, and that will give me the root. Read the instructions very carefully. Sometimes it'll say give the exact answer, which means you have to simplify the radical. Sometimes it'll say give the answer to the nearest 10th or to the nearest 100th. So make sure you read the instructions and give the answer the way it's asking you to. Okay? So that's the easy ones. I guess the harder problems with the Pythagorean theorem are where we have a leg and we have a hypotenuse and we're missing this other leg. Aren't these a little bit more difficult? Okay? So if a squared plus b squared equals c squared, in this case, what's a? Okay, you want it to be 10? Okay, 10 squared. Plus, what's b? Okay, that's the one we don't know. Does it matter which is a and which is b? You all understand that? You've done it before? Who's done that before? Okay? All right, good. And then C then has to be 115, doesn't it? Once again, you can't subtract 10 squared from both sides and say B squared equals 105 squared. You've got to square them first. Okay? And so, you know, I can do this, but I cannot say this is 105 squared. I've got to figure out what 115 squared is, and then I can subtract 100. Okay? Honestly, if I were going to do this on my calculator, I would look at this bit, and I would say 115 squared subtract 10 squared. And I would get it right to that 13,125 right away. And then what? Yep, raise it to the 1/2 power. That's the root. And so it's about 114.56. I think in this book, oops, just B. Oftentimes it will ask you to round to the nearest tenth. So we might just say 114.6. Okay, but that's pretty much it. Let's talk about some applications here with the Pythagorean theorem. There's one that I'm a little concerned about. That's an H. Can you guys find the altitude H of this triangle? How are you going to do it? You were confident and you all shook your head. Now when I say how are you going to do it, not so confident anymore. Chloe, you paying attention to this?
Yeah.
All right, just checking. Couldn't tell if you were writing notes or ignoring me. Okay, what do you guys think? Can I use the Pythagorean theorem here?
Yes.
Do I even have a right triangle?
Yes.
Okay, so I've got a couple, don't I? Okay. But do we know, let's just look at this one. Do we know that? What is it?
10.
How do you know it's 10? Because it looks like that comes down and hits in the middle?
It's an isosceles triangle.
Say it louder.
An isosceles triangle.
Okay. It's an isosceles triangle, which means the altitude is also going to be a median and a perpendicular bisector, isn't it? It's not just an altitude. If this was a different length, so if we had something like that, and I draw an altitude down here like this is 15, this is 22, this is 20, something like that. Finding the altitude in that case, that's a whole nother ball of wax. You see that? Okay. Finding the length of this bit right here, that's what we need to find. Now, is that findable? Yeah. Anybody know how to do it? Because if you can, I'm going to be super impressed. Okay. Well, let's just leave it with it can be done, and we'll worry about that later on. Okay. But that'll be simple. Okay. So Pythagorean theorem. Let me ask you about this. Is there a converse of the Pythagorean theorem? What would that say? The distance formula is the Pythagorean theorem, yes, but it's still the Pythagorean theorem. But would the Pythagorean theorem have a converse? So the Pythagorean theorem says if it's a right triangle, then the sum of the squares of the two legs equals the square of the hypotenuse. So can we do the converse of that? Can we take the hypothesis and the conclusion and swap them? So if a squared plus b squared equals c squared, then what type of triangle does it have to be? Yeah, it has to be a right triangle. So the Pythagorean theorem does have a true converse. So if I have a triangle and the sum of the squares of the two legs equals the square of the hypotenuse, what type of triangle does that have to be?
Right.
Yeah. And I think, in honesty, for me, I use this more often. I use the converse of the Pythagorean theorem more often than the actual Pythagorean theorem. So if I'm squaring up a foundation or something, or a footer or something like that, I measure the length of this side, let's say it's 30 feet, and I measure the length of this side, let's say that's 45 feet. And do I know how long this one should be in order for that to be a right triangle? Yeah, okay. I can figure out how long this side should be in order to make this a right triangle. And so as long as I make sure that's 45 feet and this is 30 feet, so I guess I'm going to use the Pythagorean theorem. Raised to the 0.5. 54.08. What's 0.08 feet? Anybody know? It's 0.08 twelfths. So it's almost one of those. It's almost an inch. 58 feet 1 inch. Okay? So 58 feet 1 inch. So I make sure this is 30, I make sure this is 45, I measure across, and it's 60 feet. Is that a right turn? Is this a right angle? Can I fix it? Yeah, I can fix it. I can move the stake over a little bit, make that a little bit closer, bring this in a little bit, measure again, and I can keep doing that until I get it exactly right. Right, Kimball? Sound familiar, doesn't it? That's something we did almost exactly a year ago. A lot, okay? So the Pythagorean theorem does in fact have a converse. That's true. I guess every theorem has a converse, but they're not always true. Yes?
So could you use something similar and say that if a squared is like greater than a squared, or that c squared is greater than a squared plus c
Yeah,
squared?
so there is a deal where if a squared plus b squared is greater than c squared, or if a squared plus b squared is less than c squared, then you know it's an obtuse triangle or an acute triangle. So if the two of them squared is greater than the square of the hypotenuse, what kind of triangle you guys think that is? Think that one's acute or obtuse? See, I think it's acute. I think this one's easier for me to picture though. If the long side is like really long, like if it's extra long, not equal to a squared plus b squared, but actually bigger than them, then that has to be an obtuse angle. It doesn't tell me exactly what it is, but it does tell me what type of. So when I'm doing this, and this turns out to be greater than 58.1, then I know this is an obtuse angle. And I know I need to close that up a little bit in order to get it to be a right. So understanding that can save us some time. Okay, I gave you the assignment. Let's get working on that. I would imagine it's going to take till about halfway through next period, since you guys all had to get tested today.